Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We believe we can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but y'all, rotely repeating steps actually keep students from being the mathematicians they can be.
So I'm laughing a little bit as you're talking because I'm listening to the things that you're saying and I'm kind of nodding. And I'm like, yes. And then I look up a little bit and I glance at the title, what we titled this episode. We called this episode Memorizing Subtraction Facts. But
oh yeah,
really, Pam. So we probably need to get into it really quickly because I'm sure there's some people who are like, what are they going to talk about on memorizing?
yeah. So Kim, I find this fascinating.
Yeah.
I'm a little bit of a wordsmith. I enjoy the exercise of debating. I enjoy really getting under meaning. I enjoy, like really understanding what people are talking about and asking them to define their terms and, like just being really super clear on things. And one of the things that has been fascinating to me is I've been working with people to build their powerful numeracy over the last 20, 25 years is this confusion over the word memorize.
Yeah.
That we really think it means something different than that, like as we're communicating. So I want to get really clear today about what we mean when we say we want kids to know their facts and what we don't mean. So the word memorize, I think, is super tricky because I think people will use it to mean that kids should rote memorize stuff. And I think other people will use it to mean that kids should know stuff.
Yep.
And even that's a little fuzzy. And so let's parse those two out. When I say that I want kids to own something deep down, then that means I want it at their fingertips. I want it to not cause a huge cognitive load for them to redo, refigure, especially find it in some less sophisticated way than the operation's calling for. I want it to be something that they own with connections to other things so that they have multiple neural pathways that are like involved in the knowing, the owning, the really having that so that it can ping in their intuition so that when they own that fact, say we're talking about multiplication facts today, when they own that fact that things ping for them, relationships and mathematical connections occur to them. They have intuition around it because it is deeply owned. Now, if that's what you mean when you say, yeah, so they've memorized it. Yeah, they have it in their memory. If that's what you mean, okay, great. Then yay, let's do that. But I think the word memorize is tricky because I think it can also mean the way you get there, the way you own it.
Yeah.
And it can mean, and so I don't know, several years ago, I stopped saying the word memorize when what I meant was rote memorize. So I think that memorize often can mean to people that we're rote memorizing something. And you're like, what does that mean? Well, that's like where I admit that it's not really understandable. It's not really figure outable. It's something that is rote memorizable. And I need to therefore have a rhyme or a rap or a mnemonic or some kind of memory technique to be able to memorize that thing. That it could be a disconnected way and something that doesn't have anything to do with it. I don't know, something about Mrs. Weeks sitting on a chair. Do I mention that here, Kim? I don't know.
No, that's a whole other podcast.
I'll mention this one that was on my kids' wall in 3rd grade that said something like 6 times 8, like the garden gate is made of 6, so it's 56. Wait, 6 times 8? And I do that wrong on purpose. 6 times 8 isn't 56. I do that wrong on purpose to exemplify the problem with rote memorizing facts, because I could rote memorize them wrong. I could rote memorize that rhyme. It should be 7 times 8, like the garden gate is made of 6, so it's 56. But if I rote memorize it wrong, then I'll get it wrong. I could rote memorize the nines trick with my fingers wrong, and I could get the nines wrong. I could rote memorize the fact 13 minus 8 wrong, and I could get it. Be real consistent about 13 minus 8. But if I've memorized it wrong, if I've rote memorized it wrong, my rhyme, my rap, the mnemonic, the way that the picture I've drawn, the story I've told, if I somehow get that wrong, then I'm going to get that fact wrong all the time. Or another alternative is I'm going to forget it. I'm going to not be able to recall it. And then I'm stuck with nothing. I'm like, I don't memorize that. I can't remember that rhyme that I had or that story that I told or whatever. In fact, I was just reading in Dr. Nikki Newton's Running Records this morning a little bit about some of the introductory stuff. And she very nicely parsed out where she was talking to students. And she said, so if this student has rote memorized the fact, and I think she used the word memorize, not rote memorized, but I'll say if the student had rote memorized it, when they get to it on somewhere where they need to have it there, and they can't recall it from rote memory, then they'll just skip it or they'll guess. Like that's the only recourse that they have. And so again, I want to just kind of at the top of this episode, parse out the difference between what does it mean to to own the fact so that, yes, I can pop it out when I need it. I can have it at my fingertips, but more than just have it as a disconnected fact that's all I have. It doesn't have multiple mathematical connections that ping, that help me intuitively do other things with it. Help me, Kim. Is there any of that you want to kind of cement?
Yeah, I mean, I think it's so good because either the word memorize could either mean something you've committed to memory in whatever way you've committed it, which is what you and I are interested in. We do want things to be automatic. We do want kids to own things. But the other version of memorize means an action of things to do to put it in your memory. And those are the things that we're not interested in rote memory. We're not interested in the rote memory, like the action of this is what we think you do over and over and over and over and over again to get it into your memory.
Yeah. So what actions are we interested in? We're interested in actions that are related to relationships. We want kids to deal with the numbers a lot and get, not just deal with the numbers, but deal with the kinds of relationships that are important so that they're thinking about doubles. They're thinking about close to 10. They're thinking about, using facts they know and then being able to compensate from there. Those relationships are the super important things that we want to deal with a lot so that those neural connections get really strong, so that in the case that we ask a kid something like 13 minus 8, in that case, when we ask them that, then if it doesn't just pop for them, if they don't intuitively just know, like say it or have it right there, that they then intuitively have things ping for them that are those major relationships that are additive relationships, so that they quickly refigure it in a way that isn't a big cognitive load. And they're not stuck with, I can't remember. I can't remember. I don't know. Nothing, or I'll guess, because their only recourse, if it was rote memorized, if they can't remember the rap, the rhyme, the mnemonic, the whatever, then their only recourse is to guess, or they don't know. Right.
Yeah. I also think that it's really important to note right at the beginning here that We recognize that people get really hung up on facts. It's a huge topic of conversation. And a lot of times that's because if you're only going to do the algorithms, then you literally just work with the basic facts over and over and over and over and over again. And so if that's your jam, if you are, I'm full on leading towards an algorithm, then I understand why it would make sense that you would say, just memorize these 144 things and we're gonna repeat them over and over and over and over and over again. It seems like it would be an easy job. It's not, but that's not our goal, right? We are about place value and magnitude and thinking and relationships. And so since our goal is different, it's not just to get answers. We are less inclined to work with facts in the ways that other people do, but we are interested in making sense of the facts as ways to work with strategies and thinking with less sophisticated numbers so that those strategies and thinking can happen with all size of numbers. That's our outcome, is the ways that we work with the facts then lend themselves towards the work we do as the numbers get bigger.
Yeah, and maybe it would be helpful to illustrate that, but I've just been using the fact 13 minus 8. So a way of addressing subtraction facts is, okay, there's these 144 separate subtraction. If I look at the deck of cards, I'm going to drill kids on these. There's 144, 12 by 12, I don't know. I don't know how many subtraction facts there are. 87, however many there are. I'm going to drill kids on those, and they're going to have these separate, disconnected flashcards, rote memorized, and however we accomplish that. But if what we're about is what you just said, but it's really about mathematical relationships and connections and patterns and properties that if we develop those with these less sophisticated numbers can extend to more sophisticated numbers. An example of that would be if a kid's thinking about 13 minus 8 as the difference between 8 and 13, that's 5. Like I can go from the 8 to the 10 is 2, and from the 10 to the 13 is 3. So that's a total of a distance of 5. If they're thinking about like that, then they can also think about a problem like 130 minus 80. In a similar fashion. They go, well, I can do the same thing. I can find the distance between 80 and 130. They can think about something like 1,300 and 800, the 1,300 minus 800. Because those problems become drastically different problems if I'm lining them up in algorithms, right?
Yep.
In fact, maybe I'll just, because I don't know that we were going to mention that today, but if I line up 13 minus 8 and do the algorithm, how many times, teachers? This is when you know the algorithm is failing your kids. When they look at a problem like 13 minus 8 and they line it up. And so now I have the 1, 3, I have the 8 below the 3. And the kids say, okay, what am I going to do first? I got to do 3 minus 8. Nope, can't do that. So I got to borrow. Let's say I'm going to bring a 10 over here. So then that 10 over there, I'm going to that 1 becomes a 0. And now what do I end up with? I end up with 13 minus 8. That's a
all
moment.
The time.
That's a moment where they're not thinking about 13 minus 8 at all. They're performing a bunch of steps. And then who knows what they do when they get to that 13 minus 8, maybe count it by ones. Again, that's less sophisticated reasoning if they're counting by ones than what we want to have happening, which is additive reasoning, thinking in terms of bigger chunks than one at a time. Let me just carry that. So if I'm thinking about 13 minus 8 by actually thinking about the difference between 13 and 8, then if I'm thinking about 130 minus 80, that becomes a completely different problem, where now I've got 0 minus 0 and 3 minus 8. I mean, parts of it are similar and the same, but I'm not feeling the same relationships. I'm not letting intuition help me reason about those similar numbers. Yeah. So also, I get why, like you just said, if you are I don't want to say algorithm oriented. That's what I was going to say. But if that's your goal, focused, yeah. If your goal has been, and we don't blame you because you grew up in an algorithm focused, probably that's the way you were taught. But if that's the way you've been teaching any of the 4 operations, then yeah, it makes sense that when students get to big numbers, that they're going to have to do these little numbers over and over and over. So they might as well just memorize those little number combinations because you're going to use them over and over in these, multi-step algorithms. That totally makes sense. But if you're trying to build relationships, well, let me stay there. So it makes sense why you would want kids to do that, which then also makes sense why you might want those quick. And you don't want kids in the midst of a long subtraction problem to be counting on their fingers or to be grabbing manipulatives and removing the manipulatives and counting what's left over, you might be saying to yourself, I need you to just own all these individual little subtraction facts in the midst of this big subtraction problem so that you can just do them and you don't have to do this stuff that takes time in the middle of this. And so that might lead you to say, ooh, I think a way to stop you from refiguring these facts all the time, let's put a time limit on it. In fact, I just read a post the other day by Michael Pershin, who is a thoughtful guy who puts out a lot of stuff, some of which we agree with, some of which we don't. But his bit was, let's give timed drills because we want to not allow kids the time to refigure, and because we don't want to leave them there. We don't want to have kids doing all this refiguring all the time. We want to give them a time limit so they're forced to memorize them.
Mm-hmm.
I think Michael, you can tell me if I'm not representing your position accurately. So I get why that would be a thing if your goal is a bunch of disconnected set of facts that I can just pop out if I'm going to use them over and over. And so I want them to pop out, but that's not our goal. If the goal is just that collection of rote memorized facts, fine, but not our goal. So maybe we can agree that if our goal is to actually own the relationships, then I want to do a lot with those relationships, because if we give kids lots of experience with those relationships and the properties and the different strategies that we can use to figure out the facts, then kids will naturally gravitate towards owning those facts, but they will have so much more as well.
Yep.
Kim, I wonder.
I'm going to dive in real quick.
Okay,
because
go.
I think that there are lots of people in the rote memorization camp who think that people like you and I mean you shouldn't do mad minutes, you shouldn't do time drills, you shouldn't do whatever. You just got to let kids think. So then there's no work to be done. And that is absolutely not true. We are not like, let kids do whatever they want. Like, get a manipulative, 5 minutes to think about it is fine. Like, we're saying, no, we're actively doing a lot of work to own them. It's just not the rote memorization work. And I think that that's really important for us to say often, because it's not rote memorization or nothing. And I think that we have experienced teachers who say, I hear you, I buy it, I see that it's not helping my kids. They stress about the time thing. It's not improving them when I do it day after day after day with no work. Of course, it's not going to help them. So they're like, okay, I'm team, I'm not going to do that stuff. And then they just do nothing. And the next year teacher's like, your kid's got nothing.
Or they come to us and say, so what do I do?
Yes.
Right? Like, let's give them that. Like, there are tons and tons of teachers that are like, okay, I'm buying in, I'm on team, let's figure these out. But now I don't know what to do because I have this arsenal of stuff to do to help them rote memorize. What is the arsenal now? Because it does take work. It takes work for kids to own them. We're just suggesting that work is not time-based and it's not disconnected drill-based. Yeah, so Kim, let's dive. What is the work? And Kim, I don't want to forget, I guess I could write this down somewhere. I don't want to forget that maybe we want to bring up the Trinity first grade thing. What happens when we do all, we're about to talk about the arsenal of things to do. What happens when kids just kind of don't? Do you know what I mean?
No, but you can tell me again when it's time to talk about it.
Okay, I've written it down. I won't forget.
Okay. Sounds good.
She's like, Pam, I can't read your mind. Okay. All right. So Kim, what is some of the work that we can do to help kids go?
Yeah. So we recognize that there are some major relationships for single digit facts, right? We have talked about those. We're going to bring them up again here. So if you didn't listen to episode 149, which was the last episode, you'll definitely want to listen to that again, because we talked at length about distance or difference versus removal as the two interpretations of subtraction. So that work is super important, having kids experience both of those. But there are a couple of major relationships with basic facts. And so let's talk about a couple of those. And
specifically in this episode with subtraction basic facts.
Yes.
Right?
Yes.
Yep. Okay.
Yep. So if there was a problem, 15 minus 8, it's
Often
Commonly
missed.
missed, yes,
Yep.
problem. So,
Yep.
so a major relationship is this idea of remove to 10. So if I'm thinking about 15 minus 8 and I'm thinking about removing to 10, then I might think about 15 minus 5, which gets me to the 10. But then since I've removed 5, I still have to remove 3 more to make the 8. So then 10 minus that last 3 would be 7. So 15 minus 8 would be 7. That's a student who's thinking about removing to 10. And it's super cool because we can anchor everything on that 10, which is the basis of team numbers, right? If you've done any work with young grade students, you know that team numbers are an important place to hang for a while
Mm-hmm.
because every team number is 10 and some more. So if we can think subtraction, go back to that 10, that's an important and helpful strategy. So another strategy is thinking about doubles.
Mm-hmm.
We are huge fans of doubling and having numbers at a very young age. We want there to be a lot of work with doubling basic facts when you're thinking about addition. And then that comes in really handy when you're thinking about subtraction. A kid who is thinking about 15 minus 8 might say, I know 8 plus 8 is 16, but that's too much. I need to just be back 1 to get to 15. So then I have to adjust one of those add-ins and call it 8 plus 7. So 8 and 7 is 15. So 15 minus 8 would be 7.
Nice. Nice. Great.
So
So
remove to
far you've
10
talked.
using doubles.
Yep.
Yep.
So I was going to just do that. Yep. Removing 10
Sorry.
doubles. Okay. No, I just
Okay.
want to make sure we kind of helping listeners sort of focus yeah.
Yeah.
Those two. Is that it?
So finding the difference, if we're thinking about not just talking about removing, so the first one, remove to 10, is a removal version of subtraction. If you're thinking about finding the difference, a kid might say, I'm thinking about how far is it from 8 to 15. Let me think about that gap between them. So somebody might say, I know 8 and 2 is 10. And then from 10 to 15 is 5. And so that 2 and that 5 was the gap. So that's 7.
Nice.
And then one of my favorites is remove a friendly number over. And this is super helpful when you're thinking about 7s and 8s and 9s.
Mm-hmm.
So if you are removing a friendly number over, and with 15 minus 8, you might say, I don't want to subtract 8. I'm at 15. I want to remove 10 because that's
Bam.
easy.
Yeah.
And so then I'm at 5, but I've removed too much. And I would say, how much too much? I've removed 2 too much because I did 10 instead of 8. So then I had to tack that 2 back on. So I was at 5, tack the 2 back on, and that would put me at 7.
Brilliant.
So
Nice.
4 major relationships that are super important.
That we want to help build with students, want to help them
Yep.
develop those relationships so that those are, they own those relationships. It's not about rote memorizing those relationships either, right?
Yeah.
It's not about
Yep.
saying, okay, kids, today you're going to rote memorize the steps for removing to 10. It's not about that. It's about giving them experiences where we, and often it's problem strings, where we give them strings of problems, where we do these relationships and we put them in front of kids and we let them see the patterns and we talk about the patterns and we make them, with that verbalizing them, the patterns get stronger and kids own them. And now they have intuition about how they want to attack a problem if, let me say, they attack problems a lot and they use these strategies over and over and over and over and over so often that they own a lot of the smaller subtraction facts. And then the ones they don't own, the few that they don't own, they quickly use one of these sophisticated strategies. They can often, with a low cognitive load, because these strategies they own the strategy, they own the relationship. So it's a low cognitive load to just quickly do one of these because they've done it. They own them, just for those few that they don't maybe have at their fingertips yet. And the more that they do that, then they might have all of them at their fingertips by the end of that. Yeah. But again, if they don't, then they have a recourse. So Kim, if you don't mind, quickly, I'm just going to give you one other problem and let's just run through those 4 strategies one more time. Okay. So if I gave you 17 minus 9, do the remove to 10 for me.
Okay, so 17 minus 9, I'm removing 2 10s, so I'm removing 7 first to get to 10, and then I still have 2 more to remove, so that would be 8.
Cool.
So I remove 7, remove 2.
Yep, so you remove 2 10. Nice. All right, let's do the doubles. How would doubles work with that?
Okay. So I might say I know 9 plus 9 is 18, but I only need 17. So then it's going to be 9 plus 8
Cool. And that's
or 8 plus
similar to
9.
the way that you just did. Oh, yeah. Sorry, I didn't interrupt. I got
That's
excited.
okay.
Um, that's similar to the way you did the 15 minus 8. If I could do maybe a different version of the doubles, I
Yeah.
might think to myself, I know 18 minus 9 is
Mm-hmm.
9. And so, but now I'm doing 17 minus 9. So it's only going to be 8. But I also
Yeah.
might think to myself, I know
8 and 8 is
8 and
16.
8 is 16. Keep
Yeah.
going. Yeah, keep going.
And then, but I needed to get to 17. So then it's 8 and 9.
Nice. And so you kind of
Yeah.
think about that partner of 8 and 9. Since we're subtracting 9, then the answer's got to be
Yeah.
8. Cool. Okay. What about finding the difference? If you're finding the difference, 17 minus 9.
Mm-hmm. So I'm thinking about the gap between 9 and 17. So from 9 to 10 is 1. And then 10 to 17 is 7. So that 1 and that 7 is the 8.
Nice. And then lastly, if you wanted to remove a friendly number over your fave.
It is my fave. So 17 minus 10 would be 7, but I removed too much by 1. So then I put that one back on and make it 8.
Brilliant. Brilliant, brilliant, brilliant. Okay, cool.
Yeah.
So we have these major relationships for single digit subtraction facts that if we work on those 4, we work on developing those 4 major relationships, it can be super, super helpful for students.
Yeah. And I think what's really even more important to us is not just that the kids have that work with basic facts and they have something that, so they don't just say, oh, I don't know that one. That's a huge bit, right? That's really important. But what I love more than anything is that these strategies are extending to higher numbers. It's not just like, let's figure out 8 new strategies for large numbers that get to 10, that remove to 10 is the same work that kids will do when they remove to 100 or remove to 1,000.
Or remove to any friendly number. Remove to any friendly number, right?
Yep.
Yeah.
It's that general remove to a friendly number strategy. Same with removing a friendly number over. That is the one of the major strategies that we use for larger numbers. Finding the difference, huge for kids in older grades, all the way up through high school.
Absolutely.
And using doubles, doubles show up a lot more. Once you're aware of doubles, I think you realize that they show up a lot more often than we
They're
realize.
so handy. Yeah, they're so handy. Nice. Yeah. So all of I'll just restate it that these 4 relationships that we just talked about, these 4 strategies extend to larger numbers. And that's our biggest goal. We want to learn them here with these less sophisticated numbers, develop them in students so that they ping then with larger and larger. And then when we go to decimals, smaller and smaller numbers. Absolutely.
Yep.
Yeah. Super.
So we're going to wrap up because I think we talked for a while, but in our next episode, we're going to dive into what you can do to build things, tangible things that you can do with individual kids and with classroom activities. So you're not going to want to miss that one. Join us in the next episode.
Yeah. So in this episode, we really talked about what the relationships are, the strategies are to build. Let's actually do it in the next episode. Y'all join us there. It's going to be great. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.